Good morning. Today is Sunday, April 19, and we are going to be working on IXL Skill L14 dilations. We're going to find the coordinates of dilated figures. So a dilation enlarges or reduces a figure, but the figure keeps its original shape. So this is kind of the next step from a transformation, which is fixed. Its size and shape do not change at all. But here, a dilated figure is similar, but not congruent to its preimage because it keeps its original shape, but not its original size. We're going to be working with scale factors. So the scale factor of a dilation is a ratio. So think division of the length of the image to the corresponding length of its preimage. So one's divided into the other. A dilation is centered at the origin, which is, if you remember on your coordinate chart, x is 0, y is 0. So you can find the image by multiplying the x and y coordinates of the preimage. And so think of it this way. You can find the image of a dilated figure by multiplying the x and y coordinates by the scale factor. That's basically saying the same thing in two different ways. Okay. All right. Don't forget, particularly where you're doing dilations, use the XY coordinate chart. Make sure you've got the plastic sheeting on it so that you can use your Expo marker here, your dry erase marker, and you can mark it up, do what you need to do and erase. Extremely important with dilations, so use this. Okay, and let's go on and look at our first example. So here we're going to write the coordinates of the vertices after a dilation with a scale factor of 5. And these are always centered at the origin. So here we have a triangle DEF, and we're going to dilate its vertices by the scale factor of 5 here. All right. So what I'm going to do is I'm going to flip back and forth between this particular sheet and the following one. So here we have the coordinates of triangle DEF, and we're going to start with D. We're going to its coordinates are at 2, -2. Now, how do I know that? It's because if you go back over to your previous sheet, D here, if you work it out, you go over here, x is -2, y is -2, so there's the coordinates as shown. E, x is at 2 and y is at -2, so 2, -2. And f is at -2, 2, so it's up here at x is -2, y is 2. So I'm going to use the scale factor to find the dilated image coordinates. So let's do it this way. So I'm going to multiply x is -2 by 5. So -2 times 5 is -10, and -2, which is the y, times 5 is also -10. So the image coordinates of this point are d prime is -10, -10. So I'm going to go ahead and write that down here. -10, -10. And I'm going to also go ahead and I'm going to graph that. So here is where x is -10, here is where y is -10. So d prime is going to be down here. -10, -10. Down here at the very corner. Okay? All right. Next, I'm going to multiply the second point, E, by 2, -10. See if I can show this both here. So, I'm sorry, 2, -2, as it's shown down at the bottom. And I'm going to multiply it times the scale factor 5. So 2 times 5 again is 10. this time, and 2 times negative 5 is negative 10. So I'm going to have the image coordinates for E prime at 10, negative 10, and I'll write that down here at the bottom. So what did I say? 10, negative 10. So positive 10, negative 10. So since it's a positive 10, negative 10, x is positive 10. So that means it's over here. And negative 10 is down here. So let me show it to you again. Positive 10 is here. Negative 10 is down here. Positive 10, negative 10. Here's the point. So positive 10, negative 10, that's our E prime. This is our D prime. Make sure I put the primes in there so that you can see that. All right, now we're going to go up to our last point. So the third point is f is negative 2, and it's negative 2 and its y is 2. So I multiply by 5. So negative 2 times 5 is negative 10. 2 times 5 is positive 10. So the image coordinates for f prime is at negative 10, 10. So I go over here to where, let's see, what did we say, negative 10? So negative 10 is over here. Let me show it to you. Negative 10 is over here, and 10 is up here in this corner. So I've got coordinates again of negative 10 and 10. I'll write that over here. And this is f prime. All right, so we can set up our new triangle. And I'm just going to use a straight edge here. So here's our new triangle. And what I want to show you too is that if you look at all of these lines and their coordinates, you'll find out they all line up with the origin. Here's the origin. Okay, so we would have to draw other lines to show this, but if, for instance, from E to E prime, that's on this line that goes through the origin. F to F prime is on a line that goes through the origin. Now, D here and D prime, if I were to sketch a line through them, they would go through the origin. So you can see that that's why we say that these are all centered on the origin. They are all in line. So here's D prime through the origin. Okay? So that's how they work. All right. So I've given you the basics, and as I said, this is similarity. The dilated points form a triangle similar to triangle DEF, and that would be this triangle D prime, E prime, F prime, the bigger one that I made that went through it. Now I'm going to show you one more example, and this example is a little different, only in the sense that the scale factor is 1/2. Okay, now think of 1/2, that's less than 1 whole. So that means our scale factor is going to make our dilation get smaller. All right, and so I'm not going to bother to go through and use the enlarged example that I had before. Instead, I'm just going to go ahead and I'm going to go ahead. If I can find my other piece of working paper. Let's see if I can find it here. Here it is. Go ahead and just do the calculations here on the paper. So let me shift back here where I got my notes. And so let's just do it this way. All right. so I've got J here, point J. Point J is down here. And you'll notice it's at x is 0, y is at negative 6. Now, a scale factor of 1/2, it's going to do this. So let me write my J up here. It's at 0, comma, negative 6. All right? And then that maps, we use this arrow to show maps over to J prime. J prime, I'll just make it in red. And its coordinates are going to be, we're going to start out with, well, let's use black. We're going to start out with the original factor, so that was, the x was 0, and we're going to multiply that times 1/2. Okay? And so when I do that, 0 times 1/2 is 0. It's just 0. So I'm going to write that as 0. And then I'm going to do my second coordinate. My second coordinate is negative 6. So that's my y coordinate. Negative 6 times 1/2. Well, half of negative 6, it's negative 6 divided by 2, or we can just say half of negative 6 is negative 2. All right? So negative 6 times 1/2, that's going to equal negative 2. Let's use the red again. All right? So therefore, J prime's new coordinates are 0, comma, negative 2. And so I'm going to go over here to where x is 0 and y is negative 2. That's going to be down here. This is my J prime. 0, comma, negative 2. All right. Now I'm going to do k. So k's coordinates are x is 10, y is negative 6. And that's going to map as follows. So k prime is going to start out with an x of 10, and we're going to multiply that times 1/2. Okay, so we can either say 10 divided by 2, or we can say 1/2 of 10, and that equals 5. Okay. And then another comma. And then we're going to use negative 6, which is what we had up above, of course. Negative 6 times 1/2, it's going to be the same as it was up above here. It's going to be negative 2. So our k prime, its coordinates are x is 5, y is negative 2. All right, so we're going to go over here to x is 1, 2, 3, 4, 5, and y is negative 2. Oh, you know what? I put j prime down here at negative 3. Let me take that out. It's supposed to be at 0, negative 2. And so that belongs here. Okay. And then we said that k prime was at 5, negative 2, so that's right here. I'll change this over to red here. Well, I guess I can't, so I'll leave it as all black. And then we're going to go to L. So L is coordinates of 10 and 8. So that's going to translate to L prime. And L prime's coordinates are, again, going to be 10 times the scale factor of 1/2, which again is dividing by 2, and it's going to be the same as what's above, so that equals 5. And then comma, and then this time our y-coordinate is going to be 8. So 8 times the scale factor of 1/2. Half of 8 is 4. Okay. So we go over here to write L prime, and L prime's coordinates are 5, 4. And so let's find that on our graph. Here's 5, and here's 1, 2, 3, 4. Okay. Now I did not write in the coordinates. This is L prime. Previous one was K. I did write the coordinates in. I didn't write the letters in. Okay, so we've got the coordinates in now. So L prime and K prime is here. L prime is here. And then the last one is M. So M, its coordinates are 0, 8. And that is going to map over here to M prime. And M prime is going to again be 0 times 1/2. And remember, half of 0 is just plain old 0. So that's going to equal 0. And then comma, and then we have our 8 again. So 8 times 1/2 again is going to be 4. And so then that means that our M prime coordinates are going to be 0, 4. Okay, so let's find that. X is 0 and 4, so this is going to be our M prime. Oops, I put that in black, but that's all right. Okay, so I'm going to just sketch this. Okay, so you've got your square that's half of it. And again, if you bother to run a line from 0 through L prime to L, you'll find that they're all in line. So that again, you're seeing the phenomena that says that your dilation factors from the vertice to the of the preimage to the image, they go through the origin, and you're going to see that with all the other points as well. So bottom line, we got 0, -2 for J prime. We've got 5, 2 for K prime. We've got 5, 4 for L prime, and 0, 4 for M prime. And that's it. We're all done. Have a good afternoon. Take care. Bye-bye now.